Hi everyone, and thank you for joining us today for our presentation. My name is Philipp. I'm from Aldi Süd. I'm a chapter lead for data scientists and an Agile squad lead for one of our use cases. Now, what we want to talk today with you about is how we use machine learning to transform our retail landscape and to basically start with a rather small-ish use case and roll it out to a global system. Now, my name is Philipp. I'm the, as I said, chapter lead for the data scientist. I'm a chapter lead. I'm a data scientist myself, and I'm happy to stand here today to talk to you about what we do in data science at Aldi Süd, and how to give you an idea of how this might look like for a retail company. With me, I have Konstantin.
Hello everyone, I'm Konstantin and I'm working as a senior data scientist in Aldi ADA, and I'm happy to introduce also to you our store manager, Pete, what our presentation is actually about.
Yeah, so this is Pete. Pete is one of our store managers. So representative, he is actually managing one of our many stores worldwide, and he's thinking of what can I actually do to make my store better, to make my store more efficient, and how can I actually help, at the end, the customers that come into Pete's stores on a daily basis. And Pete has a very concrete problem and a very real challenge. Now, Pete needed some watermelons. I don't know, a couple of weeks back I would have said because it's sunny outside and everyone wanted watermelons. Now not so anymore, but still, Pete ordered watermelons. And instead of 200, he ordered 20,000 watermelons and had the problem of having too high of a number of watermelons in his store. So that didn't really reflect the demand that the store really had. Now these kind of things happen all the time. People like Pete, store managers like Pete, do just in the rush of doing things as a store manager, did a mistake and ordered too much. Now this is where we come in with data and analytics. Now manual ordering and manual forecasting of what a demand could be is one of the key challenges that our store managers are working on. So what are actually the things that what is the actual number of watermelons that my store might need or that Pete's store might need? And even if I do have a good idea because I'm a very experienced store manager, I might still do the mistake of, human error really. So we're talking about three major challenges in here. We're talking about inefficiencies because of very time and labor intensive work inside a store. We're talking about inability to scale. So with increased complexity and volume, he now made a mistake on watermelons, but with all the items that you also know from within a store, there's a problem with the scale there. And we're talking human errors, which might lead to something like overstocking in this particular problems. Now, these are all challenges that we can make better with data and analytics. And we want to give you an idea today on how this might look like. And my colleague now will walk you through how this can actually look like. And to start us off with, data is really the key here.
All right, after Pete contacted us, we were thinking about, okay, which data sources can we actually use to predict watermelons? And I think the first thing which come to our mind are definitely sales data. So we're looking at sales data. We checked how many watermelons we have sold yesterday, how many last week, how many in the last 3 months. So we started from this point on. But I think by extending our data set, which we are using, we're improving our accuracy of our time series forecasting models. So we were looking for other data as well. So are we talking about a store which is in an inner city? Are we talking about a store which is in a rural area? So is our customer the typical, businessman in the city doing his shopping during lunch break for his after-work barbecue to buy his watermelons? Or are we talking about the family in some rural area shopping their watermelons on a Saturday morning? So these are all things which we can consider and we should consider when we're talking about good accuracy models. But it's not only the amount of data, it's also the data quality. Because data quality is key. I know many people are talking, okay, which model should I use to do my forecasting? But it's not actually the model which improves our accuracy by the maximum. It's the data selection and the data quality. And we at ALDI, we try to document our data sources in the best possible way by having our data catalogs where we have an overview of the data lineage. We have the business meaning. If there's some calculations behind some columns, we know how they happen, how they are calculated. So everything is well documented, so that it's not like that I call some business department and ask them, hey, do you have some data for me? And they send me some 4 Excel files, whatever, and some okayish bad data quality files. So no, it's really that we try to standardize this as much as possible, document it in the best possible way to not only improve our accuracy, but also to have a really good overview of the data which we have. And when I'm talking about the implementation of forecasting models, this is actually quite fast done. Now, especially in times where we have ChatGPT, we have well-documented libraries, we have algorithms which performs very, very good. So this is actually all ready to use. So the first implementation of such a forecasting model is actually done in more or less than a week. The real challenge here is how to integrate this model in our business processes. So because Pete wants his watermelon prediction every morning in a system, and he doesn't want to get an email which he then has to open where he copy paste the prediction value into his ordering system. No, he wants to have this integrated in his pipeline, in his business processes, so that he actually saves time there. And this is the real challenge here. So it's not about the model implementation itself, it's really about integrating that into our business processes. And therefore, we treat data solutions such this model real as a software. We try to do monitoring, we try to integrate logging, we try to automate all the processes as much as possible so that we don't have to take care of these things. So we take care of these things, but not when it's in production. And when we're talking about automation, we also can reach a product which is scalable. And talking about scalability is the next thing, because Pete has told all his friends all over the world, to some other store manager in the US, hey, I actually don't need to take care of that prediction about that watermelon ordering anymore, because ALDI Data and Analytics took care of that, and now I have the exact forecast every morning in my system ready to use. And all the other store managers around the world are saying, hey, we actually have the same problem. I talked to some store manager in Australia, and he said, yeah, I have way too many oranges in my store. And some other store manager in the US said, yeah, and I have way too less lemons actually in my store. How can you support us there? And this is another challenge we have and we tackle every day. It's not to just implement such a model in one country, but then to do like a global rollout and make use of that product worldwide. And it might be, so we try to standardize all the data sources and business processes really to a maximum. But in theory, this sounds quite easy, but in practice, sometimes it's something else. It might be, for example, that we have used weather data in Germany to predict our watermelons forecast, because people actually prefer to buy their watermelons with 30 degrees Celsius outside than 8 degrees and rain. So it might be that a country like Australia don't have any weather data available, and we have to include that in our implementation. Or it might be that some columns are named differently. Whatever it might be, these are the things we have to take care of, and these are the things which consumes most of the time, actually. It's not the model implementation anymore. But after that, after we have implemented the solution for Pete, and we were able to have a global rollout in the US, in Australia, and like really all over the world, like ALDIs, not only Germany, we help Pete and we help other people. And it's not only Pete who has profit from this, it's also the environment. For example, we have less waste, we have less food waste, environment is happy, and also the customer. like when the customer comes to our stores and he wants to buy watermelons and there are no watermelons available, or the watermelons took all away the shelf space and no other product is available anymore, the customer is not happy. So by building such solutions, we try to create value along our value chain. If it's speed, if it's the environment, if it's the customer, doesn't matter. We want to have a purpose for the things we implement and we work on. And this is something we really take serious as ALDI, that we don't do such things for like with no reason. We always want to have a purpose. We want to create value. We want to create benefits. And that's why we do such things. And for Aldi Süd in Germany, there's a slogan. It's called Gutes für alle, meaning like great things for all. And we really keep that in mind when we're implementing data solutions. And we have many, many other use cases we're currently working on at the Aldi. So yeah, if you want to know more about this, feel free to ask questions or come to our booth over there.
And then, what are the key points, just closing out this for now? Well, key points are, as Konstantin said, think value and benefits. I have seen many companies that starting now over the last couple of years doing data science because of the sake of doing data science, and not necessarily with the sake of optimizing something, of creating real benefit. So one of the key takeaways here is do data science to make things more efficient, to create value to your company. And the other thing is think globally, think within the maximum scope that you have. We started with Pete, and we started with a simple solution for maybe one, let's say, country, and then we scaled it out with everything that comes with it. Scaling a solution is the second step after making sure something works. So it worked for Pete, we made sure of that, and now we scale it out to make sure it works for others as well. And yeah, so closing out our presentation for now, I hope we can give you some idea on how we do these kind of solutions. For details, there's the map here as well. We have the stand right at the entrance of the hall back there. Feel free to come to us then to talk about more use cases, what we do in data and analytics. And yeah, I think we're open for questions now.
Okay, thank you very much. Now we can start with the questions. Raise your hand if you have a question. We start here.
First of all, nice presentation. I'm Leon Queens, and I have a question. What was the model you used to predict the watermelons or the?
So model-wise, it depends a bit on the use case. Now let's take something like a sales forecast, which is a typical regression model that we would work with. Regression models, typically, we start off with a simple baseline model, which for a time series-based thing like this might be some AutoML pre-trained thing that runs rather quickly, and then going into more details with something like a forest-based random forest XGBoost type of use of algorithm in there as well, which is because with these forecasting time series solutions, oftentimes we need explainability as well, and that's where tree algorithms excel in.
Have you also considered like transformer models?
Transformer models as in neural network transformers and generators. Well, yes, sometimes we do use them, but as I said, the explainability part, which is part of communicating with your stakeholders, making sure that they know why a certain forecast is as it is oftentimes very important. So, and explainability in black box models like transformer models is oftentimes not that easy to achieve. And so that's why tree-based things are oftentimes preferred for use cases where I want to be able to tell my business why we are doing things or why a certain forecast is that way. If I don't need this, then yes, transformer-based ones can be options there as well.
Are there any other questions?
Hello. I'm interested to know about the feature, how you select that feature, which feature you will consider it in your model. Thank you.
So feature-wise, when you think of what is our main source of data for these problems, well, transactional data, right? So imagine how many receipts and invoices an Aldi creates every day, which is around 100 million lines of data every day coming in. And so building features based on our transactional data is preferred because we have lots of it. So those might be aggregations over time. Those might be aggregations of different levels of product hierarchy. So these are typical features that we're working with. Other things do also include external data, like the weather example, which is something we use from time to time, or store-based information, the type of store. I'm sure you've seen this. Over the last couple of years, we had like older stores being replaced by newer stores. And just to give you a rough figure here, this feature makes out like a newer store makes roughly 25 to 30% more sales than an older one. So this is a very important feature, for example, to have.
I'm coming to you.
Hi. So my question is actually twofold. One is regarding the external factors that you've just mentioned. So I just wanted to understand like how important or how much of a role does external factors play in, for example, foot traffic to a store, which is also impacted by some other external factors, for example, another supermarket closing down, and then how does it change your timeline for the prediction model? And then other factors in the store, which, for example, is placement. Like every store has a different kind of placement. And then how do you handle different brands within a same category? Like how does that work in this overall scenario? Thanks.
So let's start with the last point with brands. Yes, brands, depending on what type of use case you're doing, might be something that is a feature in there. So it might be that we have like features like is brand or is not brand. Or maybe depending on the problem, we might even have like one hot encoded or binned brand features in there, right? But this all, and this is an answer to all your points, is very much depending on what sort of use case are you working on. To give you an example, I talked about the weather before. Now, weather is interesting in some use cases. In many others, it's implicitly in the model because of time data. Because I don't really need to know the weather if I know that in April it's going to rain more often. So overarching, this is very much dependent on the use case as well. Now, placing in itself is a use case that might be worked on, right? So there to have an optimal placing. But even there, it's very much also dependent on what value are you looking for. Do you want to push people coming in fast and going out quickly? Placement is different than I want them to move around quite a lot, and so I do the placement there different. So this is also very much dependent on what sort of value you want to drive, and then choose your model and features based on that. So I would think it this way. What's the business goal you want to achieve, and then do your modeling and features based on that.
Any other questions? Okay. Hi, I have a quick question regarding the data quality in ALDI. What are some of the challenges that you encounter, and what are some good practices you use to overcome them? Thank you.
Data quality issues come in all the time, right? It's just part of the deal of working with data is having to handle data quality. Now, some of the challenges that we have is whenever we work with manually maintained data. So for example, not every point of data that we need for use cases are maintained in central data warehouses, databases, or some system where we can extract the data from. But our manual data points from an Excel sheet that has been built by Pete himself. And so handling quality in these is always an issue, while at the same time, those data points might be the most important ones we work with. So those are issues we have every now and then. Other things come from system outages or similar things where we might have data missing or something like that. Now, how do we handle this? Well, we work with tests, data quality checks, and make sure through that the data that goes into our models is actually up to par that we need with and what we do need for the modeling to work. And another point is to have systems that help with data governance and that do data catalogs so that everyone has a similar understanding of what are we actually talking about. Do we have the same understanding of what sales is? Do we have the same understanding of what a product is or what the product hierarchy looks like? So having organizational topics like governance, data cataloging in place is one part, and then technical tests, data quality tests, and data monitoring, data drift monitorings, and so on are another part.
Okay, I think that's it. Thank you very much.
Thank you, everyone, and feel free to come to us later.